Okay, so I'm repairing an 8720C, and I've got this problem where it won't lock, and it's been going on and off for a long time, and I think I found the problem, power supply problem. So I've got to dig into this. Looks like we're hitting over voltage protection or something. I actually went through the procedure for adjusting the VCO start voltage, and it was pretty close as is, and that didn't do it. And I noticed there's like blinking lights, and then I started probing some of these test points, and I see that the power is just popping on and off on most of them. So we're going to fix that. Found out I did not show was that I've been walking through the troubleshooting procedure in the service manual, pulled this card out by itself, it's fine. Then I took all these cards out. I put this guy back in, took all these out, lights were still blinking. Now the procedure calls for removing the power connector between the top deck and the bottom deck, and this whole thing hinges out, so it's getting pretty involved, but hopefully we'll find the short or leaky capacitor, whatever the hell it is, soon. Here's something cool, how this opens up. You just lift it up just like a car hood or something. And I'm going to try to find a latch. There's got to be a latch in here somewhere. That's how you get to the bottom of it. Very cool. Okay, here we go. I found the fault. And it's this module right here, the pulse generator. When that thing is hooked up, everything gets about as far as it can, and then it craps out when it tries to do phase cal. So we're gonna have to take a look at see what's going on in that thing. This is really involved. I've got to remove this whole assembly because I think this thing is part of that thing down there. So I just want to get this out and take a peek at what's going on in here. All right, things are getting a little crazy here. Remove this whole assembly, and I just want to get to this thing and inspect it and see what's going on inside there. Okay, so looks like there's a little coax or something there that touches this contact, and it comes right out. And there's two bolts that are on the opposite side of this thing. So now we can look at this. Right. So this little module comes off this heatsink thing. I assume that's the thing that gets hot. Then there's this driver for it. Has a couple of like label as chips, but they look like transistors, and those have been replaced before, which is suspicious. And there's some solder balls kicking around in here. So from probably the rework. Two, three, four, 5 pins. 1, 2, 3, 4, 5. Found them all. Yeah, so I think should probably have a look at. I think I might just hook up this board to power and power this whole thing up again, and see if the short is still there. Because then you'll isolate it between this thing and this thing. If it's this thing, this is actually soldered closed, so I don't imagine there's a way to get in there and inspect it. But maybe, who knows? It's worth a try. But I'm thinking maybe these things, something here screwed up. The only really thing I found was that the 4 grounds here were really not soldered on well. And there were lots of little solder balls all over the place, just everywhere. From the rework as well as from who knows what else, original assembly. I could imagine that one of those may have been shorting out. So I looked in here, I saw a couple of those things, little solder balls around this pin, one of these pins. So can't quite seem to find a schematic for this board. That would be very helpful. I've connected it back a few times into the system, and it is not shorting out anymore. So I also tested this capacitor, 47 microfarad. It's fine. No short there. Yeah, not exactly sure what the problem is here. I don't see no short circuits here on this thing, so I'm going to reassemble the whole thing and try it out. And I'm just building this thing up one step at a time, because with the intermittent problem, to make sure you cleared it, you want to make sure that none of these pieces like the case or this, even the fasteners, are causing the short. So far so good. The short is back, and it seems that if I put my finger on this thing, push this thing down, it goes away. So if I do that, there. I'm pushing on the lid. Oh, it's back already. There. Okay. I think it has to do with when it tries to phase lock, because we're all powered up. Everything, one connected to the other channels, but this one is the phase lock channel. And when I hook up the IF, see, we're no short circuit, but I'll pop the IF in. This is where you sample for phase locking. And, oh, there it goes. It's trying to lock. So I think what's happening is whatever is something's going wrong, and maybe here where we drive the YIG from. So here we go. All power supplies are good. Phase lock cal error. I've got the FM coil disconnected, but the main coils on the YIG is hooked up. So I'm pretty sure it's a phase lock problem, because this thing working by itself doesn't kill the power supply, but when it's in the PLL, this has a step recovery diode, and it actually is attached to it's part of the PLL system. It generates harmonics, and then these things down convert at offset frequency of 4 kilohertz. It's a long story. But the PLL is locked through this thing. So if I unhook this, the power supply problem goes away. If I have this hooked up, the power supply problem comes back. Now, similarly, if I unhook this, power supply problem goes away. Hook this back up. Right now, power supply problem comes back. So I think it's the YIG driver on the FM coil is causing the problem. So I'm going to take a look. Now, there are no schematics for this thing at all. So the block diagram does not have too much detail. So we're just going to open this thing up. I mean, there's some big power in there. You can see the heat sink. I mean, YIG oscillators tend to draw some juice. There are usually 2 coils to change the magnetic field around the yttrium iron garnet nodule. There's a faster FM coil, and then there's a main coil. So I'm going to take a peek at the FM coil driver and just inspect it and see. So I've checked the YIG oscillator, and it's fine. I've got a pile of YIG oscillators over there, and the FM coil impedance at DC is around 1 ohms for all of my other ones, which I know a couple of them are good, and this one comes in at 1 ohm, so I don't think it's the coil. And then I fashioned this thing, just a 1 ohm resistor on an SMB adapter, and as you can see, the power supply looks good, but if I connect this up, the power supply starts flaking out again. So that leads me to believe that it's the actually the driver PCBA, and not the YIG oscillator or anything down here actually. So this is the card with the output for the FM YIG coil, and that goes through this low value resistor, and there are a couple of what appear to be tantalum caps and some other caps on this board. So I think what I might do is test some of these to see if they're any good. And particularly these ones around the circuit, and then we'll see where we land. Yeah, because there's a lot of ceramics, but there are quite a few tantalums here as well. So see what we've got. Here's what I've done. I've put these Arduino wire things on here and extended the yig out to here. So that way I can figure out which pin it is. So check it out, shorted. And if I pull the upper left pin here, power supply is now good. Okay, so we just have to determine what that upper left pin is. And then we'll have a look and see what it's hooked to and see if there's any way we can salvage the yig. Hopefully it's just a problem on the yig board itself, because this is a 2 to 20 gig yig oscillator. It's gonna be really hard to find. So hopefully the oscillator's okay, and it's just a control board problem. But it seems that is good. But I wonder too if their issue too is I wonder if the power supply rail is loaded. There's a bunch of tantalum caps and things on here on this board, and perhaps one of them is substantially leaking, and just loading that down a little bit more causes the problem. So I might investigate that too. Maybe I'll put a load resistor across this wire and see if it kills the power supply. With a typical yig oscillator load, and see. That might be the next course of action, actually, is to figure out what these things generally draw on that rail, whatever rail it is, and see if that brings it back, kills the power supply or not. In which case it would lead me towards this board more than that. And I can always run the yig off the bench supply as well, bootstrap it. So, that's another thing to try is bootstrapping. Maybe I'll do that next. So let's just figure out which pin. Check this out. No worries whatsoever here. Look at that. Look at that. So I'm bootstrapping off the bench supply, and it looks like the 15 volt rail is only drawing 200-300 milliamps, which is perfectly reasonable for something for a gas-fed oscillator. So I would say that that there's something wrong with getting that 15 volts down here, and that is definitely the problem, because the VNA is super happy right now. Whew, boy, this is an interesting one. So this is way beyond the service manual troubleshooting procedure, but we're learning a lot here, how to fix these things. So I gotta see what the hell is going on with the 15 volt supply. It seems like it's weak. It's not. It seems like it's not happy. It's got some problem of some kind. We need to investigate that and see what's going on here, because it looks like the 15 volt rail is current moding too early. It seems. Because this thing is happy, that's not drawing excessive current. I don't know what the spec is, but I'm sure 200 milli, 200. Yeah, so let's just take a look around power supply and poke around there. So I still think something on this board is drawing a little too much current, and in this driver board in the bottom here, I wonder if that's the case. But there's the 15 volt rail here. I mean, presumably that's the same one that's down here, but then there's this local LM317 doing something. I'm not sure what that thing's doing. There are no schematics for this thing, so we got to backwards engineer as much as possible. Alright, so what we're looking at here, the top trace is through a 10X probe, so it's a little noisier, but this is the 15 volt that would be going to the yig. On the bottom is the 15 volts in the power supply card, and it's seems noisy, but I mean, we're looking at, it's 15 millivolts. It's pretty noisy. It's 15 millivolts per division. So let's move this to another rail. Maybe we could try. Here's the minus 15. It's a lot less noisy. So I wonder if there's a power supply issue. It's interesting. So I'm going to keep investigating, but that does seem pretty noisy to me at 15 volts. And also the voltage is a little weak, dropped 100 millivolts or so down here. So I'm going to take a look inside, see what's going on. Keep looking. Alright, so I think I got it. There's this resistor here that's got a lot of heat damage and stuff around it. And I'm going to check that cap. That cap's getting hot, so let's see if that's the problem. I think it has to do with that. Okay, so it looks like the fuse is 4 amps for the 15 volt side. So that fuse, this thing should handle a lot more current than with the YIG. So I kind of wonder if the fullback problem is actually on this board, because we should easily be able to supply that kind of current. When we put the YIG on, it's not drawing that much extra current, so it doesn't make any sense that that would kick it over to folding back the entire bus. So it makes me wonder if something here is screwy. It's too bad we don't have a schematic for this. Okay, so what I did was I added chip sockets here and here, and this circuit here is for the 15, and this is actually the 5, the analog 5. So I swapped the chip for the analog 5 with the 15 one, and under load, as you saw earlier, we did not have an overcurrent protection fault, so that's okay, and it's good. And then I talked to a friend of mine who's a professor at Stanford, Tom Lee, about this, and he said sometimes these chips can be weak and still function, although they should be replaced. So I've ordered I found a replacement, ordered it from China, because there are folks there that stockpile salvaged obsolete chips, which I think is actually very valuable service, actually. And in the meantime, I wanted to put the weak one over here, and it works. So I checked the voltages, they're good. I wanted to check it with the board out so we don't have any over voltage events. And looking here, here's the schematic of this circuit. This is actually a schematic from the regulator board A8 on the 8753, but it's pretty much an identical board. And there's a guy who made a website dedicated to it. Is the part? It's the that regulator chip is the UC 3834. It's this thing. This is the same chip, actually. So I've ordered replacements. So now that looks okay. I'm going to put this board back in, and we'll check the whole system here. And if the whole system works, then we'll button it back up. There's a lot of stuff to do, including replacing a surface mount capacitor and all kinds of crap. So, because this analyzer is in pieces right now, so more soon. All right, so everything's working now with the fix, the temporary fix, until I get my chips in, ready to go with this, and time to button it all up again, because man, there's a lot of shit that I removed from this thing. But it's looking good. I love it how I could just turn it on now, boots up without any phase lock problems. That's really nice. Okay, here we go. The moment of truth. Let's see. And there it is. Everything is phase locked just fine. Great. Okay, this thing is now repaired. That was a big repair. Much harder and non-obvious than it seems. So there you go, how to fix the phase lock loop on an 8720C. I'm sure you have the same problem with similar vintage network analyzers. You probably have the same analog, linear regulator board. And this thing is now running, and time to get back, press it back into service. Okay, so here's a cool suggestion from a friend of mine who's a professor at Stanford. His recommendation on the fixing the power supply if we were desperate, which I'm always desperate and I wish I would have thought of this, was to add a transistor onto the tack a transistor onto the weak regulator chip. Because tack a transistor onto the weak regulator chip because the beta is obviously weak on the weak one that I found, right? Here's the output of that regulator chip. And Tom noted, and I did not notice this, but he figured it out real quick, that you've got access to the collector, emitter, and if you go around this way, the base of that transistor. So you could, between 14, 13, and 12, tack another transistor onto the pins of the chip to increase the beta of this guy. So put another transistor in parallel, thereby increasing the beta of this one, and you could get away with not even replacing the regulator chip at all. So that is a cool trick to remember next time. So whenever you encounter a regulator dip chip that's weak or not working right, pull the data sheet, take a careful look at its output. You might have access to the pins. If it's working but weak, like this one was, you can actually tack a transistor onto it and make it work again, because the other stuff behind here is working just fine. It's the output that is sagged over time and load. So that's my last final tip on this. Well, actually it's from Tom Lee, but I love it and I plan to do it next time. And I will always look for that trick. Just take a look at what's hooked to the pins of the IC and see what you can do with a linear IC.